Welcome back to our Scala to Spark class. On continuing our day 33, we will look at some pre-processing and feature engineering today, how to pre-process our data. Again, arguably the most important task in your data engineering career, everything but it's most involved. But before that, on our pipeline, again, we created our previous lesson. We were able to save and then load the model. How we do this in like I said, the real life scenarios, deployment. How could it work? Like for example, what I showed is how to load the model from a disk. That would be again very typical for classification regression task. Let's say for recommendation engine, of course, this is a different task. You store basically in database the key value, your recommendations. You create them. You create all possible recommendations already, basically for your key by keys. Basically, the book, let's say book or movie key. And value would be the recommendations, because you don't want to waste time basically running the model, right? But of course, when you have data you just cannot look up the key value. You don't know what kind of values you're going to get, right? Then you need, of course, have the model, right? So this, of course, takes more time, right? This request, you have a request and you have this, right? Recommendations, basically you only have it. You have all the keys already pre-made, right? So this is more, like I said, more offline. We train it offline. So offline means, we take it without. It's not a ongoing process. You just do it at one point, right? And also there's some other ways, right? There's some other combination. You could train it offline, like we did, do it to disk, but then maybe again, since we know starting up Spark might take a while. Maybe you need to leave it running, perhaps, right? Again, this might be painful a little bit, right? Also, maybe do it manually with some other software. Basically, have a model which runs quickly on a single machine, right? You can do it to another. Right, there's some other solutions possible. You can export it to some other machine learning interchange models, basically, right? And of course, the most complex would be to do it online, right? And use it online, meaning you have more data coming in, right? And in streaming mode, this would be the most complex, right? This, of course, you probably wouldn't want to do this alone. You have probably multiple people working on this type of project, right? But of course, there are other ways of doing it as well, right? So those are we saw the core concepts in machine learning in general. Let's look now at our pre-processing. So this is the biggest challenge, basically, and time consuming is pre-processing. Again, it's not too hard programming wise. I don't think you'll have any problems. It's just mostly about the knowledge of your data, what you're working with, right? Understanding what you need, basically, right? So so I will talk about some of the details what we can do. You already learned a little bit about R formula, but there's some other ways of working with data. Again, you don't have to use R formula all the time, right? But so different tools which are available by Spark. Okay, so we need to process our data, pre-process the data for different objectives, right? So if you're doing classification or regression algorithms, right? Well, you will need the type double for the answer, for the label, and a column of type vector with either dense or sparse vector with doubles which will represent the features, right? Of course, if you have recommendation, you have key, column of items and column of ratings. If you're doing unsupervised learning, right, which means you don't have the answers, basically you basically do it. You need it basically this vector. Basically, that's all you need. You don't have a label, right? Or you could, of course, if you do have a label, you can pretend it doesn't exist, right? Nobody's forcing you to use a label. If you want to do unsupervised learning, you can do it. You can check with some supervised learning methods, of course, right? You can pick and choose, right? And in graph analytics, you'll need data frame of vertices and data frame of edge. We won't cover it in this course again, the graph analytics again, but that's an interesting area which I personally like doing. But of course, it gets quite complex easy. So basically, the idea is you have transformers, basically functions accepts data frame as an argument, in comes data frame, and out comes data frame as a response, right? So we will look at we won't look at all of them, but we'll look at some particular use cases. Okay, so this is the whole thing I'm gonna copy here, right? Chapter 36, preprocessing and data engineering. So we will do this here. I will create a new new day 33 class object day 33 processing, right? And of course, again, these ideas will be important even if you don't do much machine learning, but the ideas of how to wrangle your data, basically. That's what we are talking about here, right? And so print line 25, right? Okay, let's do this. And of course, I will want my Spark, right? My Spark key, get Spark. Okay, we're good. Let's run it, and we'll have to do some again. So we have our data, right? There's again, so we'll read some data sets, right? So again, I think I have these integers, simple MLS scale. Okay, yeah, I think I have all of these. Okay, so fake integers, simple df, and scale df. Okay, let's read all three. And also we have retail data by day. So we have 4 sales, fake integers, simple df, and scale df. So we have 4 data frames, right, to get started. So let's see. Of course, I will need to adjust this, right? So I will need to raise some data, and I will need to do this here. Okay. Right, and of course, nicely, I like this, how it shows what you have, reader, options, right, still a reader, and the data frame, again, data row, of course, data frame. Okay, so we have 4 data frames. We should have all 4 data frames, but, of course, this is source resources, right, source resources, so source resources, right, and I need to, of course, I could do this here. Can I do it? Let's see, Control H works? No, not Control H, I always keep remembering Control R. Yeah, Control R works. We want to replace it with what? Source resources, right? Yep. 3. We have where's we don't want to replace this one, right? No. Okay, replace. I hope it worked correctly. Yeah, looks okay. Looks okay. And that's it, right? Do we have any other more resources? No, that's it, right? All right. So Control save and let's run it. Right? Let's run our code. Okay, our copy replace worked, and it should work. The code, the paths should work because we have them here, right? Yes, source resource simple ML integers. Again, this is, I think, Parquet, of course, right? That's a Parquet. Scale is a Parquet. Simple df was integers, right? Simple, that's Parquet, and JSON was simple, basically simple df, basically, right? Yeah. Okay. Again, that's JSON, right? Yeah, okay, that's we used before. Okay, and we also are going to load all of our retail dates, right? Load all of it, right? Okay, let's run it. And we don't want a null description. Okay, let's see. Yeah, sorry about that. I, of course, again loaded the model, which is good, of course, but I will need to do this. Yeah, that's previous. Let's do this one. Again, version 3.22, right? And we should be getting loading all. Again, of course, this takes a while, right? Because this is a wildcard, right? Okay, yeah, it worked fine. Okay, great. So let's proceed, right? So we have feign, right? So right, since by the way, here's an interesting point, right? Since we want to access this data sales cache, right? Right, so of course we know this, of course we used this before quite a few times, of course, right? So false, 10 false, right? Of course we know this, right? We could of course use this load my CSV loader as well, right? Of course this is the same thing, only difference, this is actually 5 partitions actually, right? Right, with specific partitions, right? So technically we could do one, right? This, okay, Again, of course, 1 is because we only have one machine. Again, I'll leave it at 5. Again, possibly, there might be some improvements even on local machine since we have multiple. Well, maybe multiple partitions might help. Okay, right. We have again. Right. So this is one of the things is that one of those things is right. So important note, right. So we reported description is not null, right? Because remember this is data frame already, right? So we didn't want a null. So caching is basically for default storage level, memory and disk. So this is for quicker access. Okay, since we're doing a lot of, if you're be working with some, of course, some data set. Again, this is I remember this is about 500,000 rows, right? Entries, records. However, if you have 500 million, they might not fit in your memory. So caching might not be even possible at some. If you have too much data. Okay, but that's okay. So transformers. So basic idea is that, right? So So basically, right. So transformers is this picture here. So transformers look like this, right? So idea is this: something comes in, something comes out. Data frame, right? Let's say at an input column, right, and what you want, right? So you'll have a data frame, and you have a new column added with this, result, right? So Tokenizer, for example, right, would be a good example, right? You could tokenize string, split on some character, white space, for example, right? It doesn't learn; it just basically applies a function, right? So this is basically example. Tokenizer from description, we should see the default, right? Transform, right? And we have, of course, an array of words. And notice how else it will be automatically. I think it is gonna lowercase as well automatically for you, right? Kind of nice. Again, of course, there's the option to change it, right? So quite a nice. So for example, so example how do this, right? And of course I need to import it. Import class. There's other tokenizers for DNS tokenizer. No, we're not working with DNS data. That's not DNA, but DNS. But for billing, I think something like so. Of course, machine learning tokenization in working with text is quite important. So we'll have transform, and we'll show again. I don't know. Show maybe 10 columns. Okay, let's run it. Right, so we should see this. So that's one tool basically. Again, so transformer, classical transformer, something comes in, something comes out. Basically, you don't change the original sales, won't be changed. You'll have, of course, so you supply data frame, of course, so this will give you a new data frame. You could save it again at this moment here, right? Transform returns a data frame. So we could save it basically and then show it later, of course, right? Yeah, of course, so nice, right? And I believe, is it actually knick-knack-tins? I forgot about, I don't know if it's gonna get doubles, get rid of doubles. Let's check. Do we have any doubles here? That might be an option. Let's check, let's take a look at this. Do we have any set input column? I think you can select transform. There'll be option. You need to read about this tokenizer. There's a way of doing it also for uppercase, of course, right? So again, very typical task in tokenization, right, is to do this type of transformation. Okay, so very nice. Right, so estimators, right. So second tool is, of course, why do you need this? Because sometimes your pre-processing, you need to do some, so to say, you need to do initial pass over some data to figure out how it's going to work actually, right? So you need to estimate how to work, right? So example here is how to scale data, right? You need to scale data, and you can't just blindly perform, right? You need to know how to scale it, right? So that's why you need like two passes. You need two passes, right? So again, right? So this is an example here, right? So this is estimators, right? Right? Right, so first you do a fit and then you do a transformation, right? So an example would be a StandardScaler, right? Basically, which scales your input column. You have your inputs, right? you have a 0 mean, meaning 0 average, right, and variance of 1. So what does it mean? Right, in statistical terms, right, you have 68% of your data within from 0 to 1 and 0 minus 1, right, scaled like this, right, you scale to this type of format, right, mean of 1, right, variance, right, so very squeezed together, right. So of course this means also standard deviations 1, because of course you have variance 1, right, if variance is 1, standard deviation will be square root of 1 is 1, of course, right, like here of course you see how it's different. Again, remember that variance basically tells you how the data, how is data distributed in your data set. Okay, so let's look at an example here in the book. All right, we say scalar, what column comes in, and then we do okay. So the difference will be that right, so difference will be that we need to provide do it sort of say two-pass process basically, right? Estimate and then transform, right? Of course, since this is so we create our scalar SS, I don't know, I'll say StandardScaler, right? So I need of course import it, import class again. There's two of them. Again, remember I think this is a new. We need a new one. MLlib is the old one, I believe. Let's double check if I remember correctly. Yeah, it's a new one. Okay, and the MLlib, the other one was for the RDDs. RDDs. Resilient distributed dataset, which is depreciated. Again, you can still use it if you want to, but you don't really want to. You don't really want to use it. Okay, and then occurs. So now we will fit it right like this, right? So of course it will fit the features, right? We said okay, yeah, we want to work on feature columns, so it will scale them, right? And of course here it is kind of hard to see what's happening. Maybe I will have a, let's see, what is it, Scala df. Okay, what's in Scala df? Let's see what kind of data we have. I'll run it. Of course, you'll see this in the action, but it'd be nice to see it also in a simpler, what it does actually, right? Okay, so scaling, it worked again, of course, these numbers. Okay, so basically it went through all each column, I mean, in features, each index, right, in this features column, and scaled it according to these values here, right, all of them, of course, all, whatever how many you have, right, and again, with the goal being that the distribution looks like, looks like this, basically, this is, it's average 0, right, average mean is 0, but 68 values are within -1 to 1. Let's take a look. If I would like to show you this example, let's see, can I fit something really simple? Let me do one more column or data where we read our data, our estimator, right? Let's see. Was it simple df? Let's see, what did we read? Scale, scale, yeah, scale. Okay, scale. We can't see it actually. What data is looks like. Okay, I'll make a new data frame for myself, right? And maybe can I do this? Can I do this? Df equals sequence. Let's say 0 to, I don't know, 20, right? On to array. Can I do this? Right, it is a sequence, right? Can I do to df, right? I can't, right? Because import the Spark implicits. All right, will this work? To sequence, I think. Yeah, it works now. Yeah, okay. And I forget, let's see how it looks like. df show, right? Let's see. Oh, maybe I don't need, oh, yeah, it picked up. I don't need this because this is only sequence. So kind of cool, right? df show, right? I like doing this. Oh, yeah, okay, what we called value, okay. All right, so of course it's value. I could just rename it, features. Let's try this. See, so select value as features, right? Right. Let's try that one, right? So we'll have a just single column, right? Or you could rename it, right? Of course, that's a simple, easy way of doing it, right? Again, that's why it's so nice, because you have this immutability of data. You can do these transformations, not worrying about, your data flows, basically, right? Adjusting as needed. Oops, nope. Select expressions or select. Oh, I need expression. Select expression. I guess I do need to do this expression. Yeah, I always do. Oh yeah, I think I need one more time. How are we doing this time? We're doing good. Okay, so these are features. Okay, so now the question is, can we use the same scalar? Because we said, okay, features, okay, SS, right? We maybe could change it anyways, but okay, I think it will work. Let's try this. So df, right? No, SS, fit, right? df, right? You need to, of course, provide it to first has to learn, right? So it has to learn. So our scalar first needs to learn fit how to scale, then we scale transform. Basically, that's the idea. Okay, so let's take a look how it works. Fit and transform, right? df, of course, and show everything, right? So let's see what it'll look like, right? So average, of course, we want a mean. We'll see how it's distributed. It will be interesting to see. I'm kind of curious. I wonder if it's going to work, because features, it should work. Again, because of course, it's a model, right? It's a scalar, right? So technically, it should not, because we're doing it here, right? I'm fitting, if I did it here, of course, if I skipped, basically, because this returns what? It returns an estimator, right? It runs a standard scalar model, right? So if I did fit on something else, right? So basically, it would think it would do a incorrect transformation. That's why usually you would want to have these matching. Of course, if you did it on a different data set, of course, you'll have a different transformation. Maybe not what you want, right? So this is, of course, 0 to. So we'll see. Nope, it did not work. What didn't work? Why didn't it work? Vector. Oh, right. Okay, right. It needs a vector. On what we didn't do it, we need to vectorize. Right. Okay. Yeah, because of course these are just regular vector value. I believe. Could we do vector as vector? Can we do this? Let's try it. Yeah, right. So we need to do, of course, Spark MLlib convert value to vector. Right? We did this in the book, right? So, right. There's no documentation here. We want to do it. Can we do it with SQL? I would like to do it with SQL, right? Main guide. This is a new one. No, we want the old new one. No, that's old Spark. We'll do 3.2. Oh, look at all this documentation we're gonna do here, right? Okay, Spark overview, API, MLlib, right? And loading data sources, right? And we want the vectors, right? Yeah. So we could do this basically, right? And then we could pass it to df. I think we could do this. Oh yeah, maybe we can do this. It'll be easier, right? I'll do it immediately, right? Since I'm lazy, I'll do this vectors, right? Remember, this is vectors, right? This is from data types. Okay, so we'll do that vectors dense, right? I think I can do this, 2 vectors. Can I do it immediately? Instead of 2 here, can I do 2 vectors? Let's see. I'm not sure if this is correct one, because this is yeah, it's not the one, not the one, right? So what we want is, can I do this vectors, right? Yeah, I think so. Vectors dense, maybe. Let's do dense. Let's do dense because of course it is dense data, right? Import. Yeah, linear algebra. Okay, do we need dense? Oh, I guess I don't. Can I do this? No, I can't do that, unfortunately. So, dense, and I need, of course, this to sequence, right? I guess this is, well, I need to unroll this, I guess. Well, let's see, can I do to array? Yeah, this will be, yeah, to array. Can I do this? Nope. Yeah, so vectors pass array. Can we make it 2 vectors? Can we do it now? Let's try this one more time. 0 to 10. Can we do it 2 vectors? I would like to do it. No, I don't know if we have vectors. It would be nice. It would be nice. No, just that's a regular vector, right? So that's why it's kind of pain. Right. Vector value. We could do vector value. We'll do that. Might be nicer. So Spark SQL vector type. Let's try this. Yeah. Right. Vector type. Can I do it with SQL? I want to do it with SQL. No. That's not what we want. That's not what we want. So let's see. Let's look at our book as well. You talked about this here. Vectors. Yeah, VectorAssembler. We're actually kind of skipping ahead of this chapter, right? Right. We'll need almost everywhere, right? We'll need basically. Yeah. So we can use that. Okay. I guess we'll use that. We skip to the. I guess we'll use that. So right. So. It will help you concatenate. This is which we did in our formula, right? By hand, which that did for us. So this actually is. We'll use that actually. Official VectorAssembler, I guess, would be a way of working, right? So basically, so right, right, and so we have our so value features. So that's what we're gonna call it, right? And we'll need to again, so this is of course not needed, right? So this is fine, this was fine, right? Yeah, okay, that's all good. But now vector df, do we need to store it? Yeah, we can do assembler. So this is a VectorAssembler. This is kind of good actually, right? We can skip this. I thought there's an easier way of doing it, but I guess I try to sort of skip it. So, basically I will set just a scene. Okay, so let's do 2 columns, right? We can do, and maybe, right, we could do with div show, RESTful expression, and let's add some more extra stuff, right? We can do this, right? With column, right? Feature 2, right? F2, right? And we'll do expression, right? Maybe, you know, F1, right? Doesn't really matter, right? or value. We don't really need the name for this, right? We don't need it. It's just value, right? Do F1. You know, I don't know, times 2, right? Times plus 5. You know, times. Times, I don't know, times 10. Something like that, something silly, right? Okay, you need, of course, import expression. Okay, right, and let's see if this works. F1 plus 5, okay, looks okay. And we need, of course, to name it, right? This is... as, I'll just call it as F2. Oh, no, actually, no, it's already here. Okay, so we're good. All right, we're good. So let's see if this works. All right. This won't work, right? Let's see. This we have 2 columns. So it should work, if I'm not mistaken. Okay, it worked. Okay, yeah, it worked. F1, F2, everything worked. Okay, great. So we're good. So I want to show you. I expect my thesis is that my hypothesis is that this will actually give you same scaling. Okay, all right. So we are going to. So. df so we're going to scalar, right? Features, right? We said it's feature. Of course we could rename this, we could use different, we could create new scale, but now we can use VectorAssembler, right? So we'll use F1, F2, right? Vector, right? VectorAssembler. We need, of course, import it. That's fine. So I'm not going to use this one, right? I'm going to use the whole other one, right? I'm going to use it, right? So F1, F2, right? And I don't have the third one, right? I don't have the third one, right? So transform, right? Into this show, right? Let's see, and of course I'm not going to use fake IDF, I'm going to use just DF, right? Let's see that. So this is VectorAssembler, and it will give you, this transform will give me a data frame. Okay, let's take a look. So it should give you a new column called, we'll see what the name it is. Okay, let's take a look if this works. Yeah, it worked fine. So we have a vector. So that's going to be our feature. So of course the name is something like this. Yeah, the question is, can we transform? Can we create a new name for it? Actually, that's the only thing is VectorAssembler output, right? Could we create this name? I don't know if it mentions here. It'd be nice to have a name for it, right? Yeah, because of course, how to set the name of VectorAssembler, right? Let's see, was there an option here? Yes, it output. So let's do this. I think you can. Let's try this, right? This is your input, so why can't you set the output? I think you can. I'm pretty sure you can. Set output. Yeah, of course. Features. I'll call it features, which is of course coincidentally, right? Right. Of course. Otherwise we get the long hash type and column name. Right. So let's run that. So now we should have just a regular features name. Okay, all right, we have our features, right? Okay, now let's see, can we do this? Well, of course, we could, this is going to give you a data frame. So that's going to be here. We need to do it twice, right? Yeah, we do. So I guess we do need to make it, it'll save it. We'll save it, so df assemble, right? Well, of course. Show, right? And now it should work. Let's try it. sfit df assemble, right? And also transform df assemble, right? And we should show this what's happening. So my theory, well, my hypothesis, since these are exactly the same data, it should scale to same type of results. It will be interesting to see. I expect it will be same, but we'll see. Okay. Okay, actually, they only give me one result. Huh. Output. No, it's two. Oh, actually, it has false. Yeah, okay. Yeah, false, and it'll be interesting to see. It's not the same result. Apparently, it's not the same result. That's very interesting. Yeah, actually, I guess not. Well, why? Well, the mean on, so because my transformation apparently was, you know, the double, so result will be slightly different, right, for these, because you need to have an average 0, remember? Let's take a look. Or scaling, how did it work? Let me see again. Scalar, right? StandardScaler, right? Of course, we would need to check this. Let's see this result again. Okay, 20 rows. Yeah, it's scaled. It's, yeah. So there's a slight difference. So it's not. It's actually so. Since they are positive, right? 0, right? Scales. Look at this interestingly, right? So 0, 0, 0, 0. How is it that mean? I'm just trying to figure out. I need to probably check it out. It's actually the mean does not, obviously does not look to be 0, right? The mean is not 0, right? So StandardScaler, maybe you need to check, of course, what exactly it does. Scaling, right? Transforming. Where is our select feature? Transformer. Select StandardScaler. Okay, there it is, right? Okay. So this mean, this is the false. Okay, so here, okay, it is false. So mean is not used. So mean is not used. So you can change it actually. I will add this here. You can see this. So if I change it, right, I'll make new scalar, right? I'll call new scalar. Will be what scalar, right? Is gonna be, or this, or friend here, right? Right. And I think it's here, right? Also I could also set output also, but I could do it. Is there a code? Yeah. We transform, of course. Yeah, you can see here. Yeah, here, set with mean true. Okay, yeah. So I'll give you all of these, right? like this, right? All of them. And mean true, right? Default false, right? And let's see, we can do it. Basically do this, right? Scalar with mean, and we can use this, right? So it should be different, right? And I will provide you an exercise after that. Okay, let's take a look. Yes, indeed. Okay, this now makes perfect sense now. That's what I was wondering. That's why you always have to pay attention some of the hidden parameters, right? Why was that mean not used? So now its mean is used. Of course, now it's exactly the same. You see, now it's exactly the same. The mean, it's centered mean. So, of course, it's because my transformations here didn't really do any in effect regular scaling here. You see, of course, the average 0. This is the middle one. So 66% of data should be between -1 and +1, which is roughly the case here. Okay, so now our data has been nicely transformed, and we will see about a nice exercise.